Okay, from 2016, the differential equations problem on the AB exam, I'm only looking at parts A and B here. The first one, they give you a slope field. They will always tell you how many points are included, just so you know specifically how many to look for, because sometimes the points that are on the axes are a little bit hard to see. So make sure that you find all 6 of them. Every now and then give a problem, a slope field problem to my students, and they'll just forget to include a point. So all we're going to do is compute the slope at each of those 6 points and then draw a small line segment with that slope. So I think it's safer to do a table. You don't have to, but I think it makes it a little bit easier. So at the point 0, 2, if I plugged in that, I'll be 4 over -1, so that's going to be a slope of -4. At 0, 1, that's 1 squared over -1, that's -1. At 0, 0, 0 over -1 is 0. Plug in 2, 2, 4 over 1 is positive 4. 2, 1, that'd be 4 over, whoa. Yeah, I'm sorry, whoa. Okay, I'm sorry, plug in 1 for y. So 1 over 2 minus 1 is 1. And plug in 0 for y, you get 0 over 2 minus 1, which is 0. And then we just sketch those. They don't have to be exact. What they will look for when grading this is they want the zeros to be accurate, because zeros are very easy to do. You just draw a little horizontal segment, As for the rest, for example, at 2, 1, the slope is 1, and at 2, 2, the slope is 4. All they're going to look for is increasing steepness. Are their slopes okay in relation to each other? So if I wanted to call this a slope of 1, I could call that a slope of 4, and it is steeper. That's all they're looking for. What I like to do is I like to imagine if this is supposed to be a slope of 1, that means I'm going to go down 1 and left 1, and I'm going to imagine connecting it to that point at 1, 0. And so that'll make it a little bit accurate. A slope of 4 is really steep, so that one I wouldn't bother trying to make it accurate. So I'm just going to make it really steep. Over here we have -4 and -1, and so there's your slope field. Pretty easy. And then part B asks you to write the equation of a line tangent, so you need a point and a slope. The point at x equals 2, they tell you is at 2, 3. And then the slope is going to be the differential equation at the point 2, 3. And this is annoying because we have not done that yet. I was hoping that we could pull one of the slopes off the slope field. So now I have to go back up, and the derivative is y squared over x minus 1. So 3 squared over x minus 1 is 9. And so my tangent line is y minus 3 equals 9 times x minus 2. And then we are estimating f of 2.1. So f of 2.1 will be approximately 9 times 2.1 minus 2 plus 3. And I would encourage you to stop right there. You do not have to simplify it. However, that does clean up to 3.9 if you so desire to do that. And that is all I wanted to look at on this one.